The third problem states that a mass weighing 8 pounds is attached to a spring. When set in motion, the spring or mass system exhibits simple harmonic motion. Determine the equation of motion if the spring constant is 1 pound per foot and the mass is initially released from a point 6 inches below the equilibrium position with a downward velocity of 3/2 foot per second. Express the equation of motion in the form x of t is equal to a sine times the quantity omega t plus phi. So first we will list the given. We have the weight which is equal to 8 pounds, the spring constant which is equal to 1 pound per foot, the displacement from the equilibrium position which is equal to 6 inches, convert this to feet, and we will get 1/2 feet, which is also equal to our initial displacement x of 0. And our downward velocity 3/2 foot per second, which is also our initial velocity x prime of 0. So first we will get mass m, and in order to do that we will use this equation, m is equal to weight over gravity, and substitute wrong values, so we will get m equals 1/4 stub. Using this, since we have a simple harmonic motion, we will use this equation and substitute the value m 1/4, and since our spring constant is equal to 1, we will get 1/4 d squared x over dt squared equals negative x. Multiply both sides by 4, we will get d squared x over dt squared equals negative 4x. Transpose negative 4x to the left side, we will get d squared x over dt squared plus 4x equals 0. And from this equation we can conclude the omega squared. So our omega squared is equal to 4. Simplify this and we will get 2. Omega is equal to 2. So from this we can now substitute this to we have two in motion, and one of this is this one, x of t is equal to c sub 1 cos sine omega t plus c sub 2 sine omega t. So let's substitute 2 to omega, we will get this one, x of t is equal to c sub 1 cos sine 2t plus c sub 2 sine 2t. And then differentiate this, we will get x prime of t is equal to negative 2c sub 1 sine 2t plus 2c sub 2 cos sine 2t. It was mentioned from the previous slides that our initial displacement is 1/2. So we'll just substitute, we will have t equals 0, and using, so this is it. We have x sub 0 is equal to c sub 1 cos sine 2 times 0 plus c sub 2 sine 2 times 0 equals 1/2. Sine 2 times 0 is just equal to 0, and cos sine 2 times 0 is equal to 1. So we're left with c sub 1 is equal to 1/2. To solve for c sub 2, we will use this equation, and it was mentioned from the previous slide that our initial velocity is equal to 3/2. So substitute, we will get x prime of 0 is equal to negative 2c sub 1 sine 2 times 0 plus 2c sub 2 cos sine 2 times 0 equals 3/2. Sine 2 times 0 is just equal to 0, and cos sine 2 times 0 is equal to 1, so we're left with 2c sub 2 is equal to 3/2. Multiply both sides by 1/2, we will get c sub 2 is equal to 3/4. So using these values, we will now get the equation of motion for this equation. So it is x of t is equal to 1/2 cos sine 2t plus 3/4 sine 2t. Since the problem was asking for equation of motion in this form, so in order for us to do that, since we already have our omega which is equal to 2, we'll simplify this to this. X of t is equal to a sine 2t plus b. And then in order for us to get a, which is the amplitude, we will use this equation. A is equal to square root of c sub 1 squared plus c sub 2 squared. Substitute the values, and then we have a is equal to square root of 13 over 4. And to get phi, we will use this equation. Tan phi is equal to c sub 1 over c sub 2. So substitute the values for c sub 1, c sub 2. First, we will transform this equation so that we can easily compute this. So we have phi is equal to arc tan c sub 1 over c sub 2. And then substitute the values. We get phi is equal to 0.5880. And then since we have the amplitude and the phi, we can now get the equation of motion. X of t is equal to square root of 13 over 4, which is our a, sine times the quantity 2t plus 0.5880.